Share it going. Okay. All right. Okay. Hi, everyone. As Ann said, my name is Alex Antonison. I'm here to talk to you about a nerdy dive into data tools. Who am I? I did my undergrad in industrial and systems engineering from University of Alabama in Huntsville. My first job out of school, like a lot of people, I got a job as an analyst. But I ended up doing a lot more data engineering work. I didn't know it was data engineering work at the time, but I ended up doing that because the existing analytics processes at the company were very manual, slow, and error prone. And, fortunately, I had some friends in computer science that were software developers, and they taught me about relational databases, showed me shell scripting. And I even built my first ETL app was in C#. Not that C# is a bad language, but I definitely don't recommend building data solutions like data applications in C#. But I was able to help reduce the analytic process from days to hours, and it was completely automated. And I really enjoyed that. So then I kind of went from job to job doing a lot of more data engineering work, getting more sophisticated like data warehousing, then moved on to building data lakes. But I also saw the value in data science and got really interested in it. So much so I got a master's in computer science and data science from the University of Illinois, Urbana-Champaign. Sorry, it's a bit of a mouthful. And fast forward to today, I have my own consulting business where I help my clients grow through helping them build scalable data applications that help foster efficiency through growth. And I also do data solutions consulting work for the Middle Tennessee State University Data Science Institute. Okay, so before I dive into data tools, I always like to kind of have a purpose of why do we care about data tools? Quite simply, data tools exist to kind of help us solve data problems more efficiently. I mean, taking out of the consideration, if you're just doing something for fun, like if you're actually using Python or SQL or something, you usually have some sort of problem you're trying to solve with it. And I like to borrow, the project management quality triangle of time, cost, quality. And whenever you're picking a data solution, a data tool, it should really be helping you either save time, reduce cost, or improve the quality of the data solution you're trying to be. And if you ever find that it's not doing that, you really need to kind of take a step back. Some general steps I take when I'm picking out a data tool. First, and I cannot emphasize this enough, you need to have a clear problem statement. This is going to help you kind of, when you're searching through the solution space, it's going to help kind of narrow you down. Are you working with terabytes of data or megabytes of data? Is it batch processing or is it streaming data? These are all kind of questions that if you can have a very clear understanding of what you're trying to solve, it's going to make give you much more easier time of figuring out what tool is best suited for you. Next, see what tools are already being used. More often than not, especially if you're working in a larger company, there's probably already an existing tool in place that could solve the problem that you're trying to solve by bringing on this new data tool. And by bringing on redundant tools to an organization can oftentimes increase your overall tech stack complexity, which can cause problems. So it's usually always better to see what tools are already in place and see if those can work for your use case. And that, if you identify it's not, then that's where you can make that use case for bringing on a new tool. Last, but of course not least, not all problems need state-of-the-art. State-of-the-art tools, more often than not, typically carry a lot of overhead, and they require specific skill sets. So, it may be, Spark is really interesting right now, but to run Spark, you need to have in-depth understanding of the inner workings of Spark. And depending on how you're going to run it, if you're a small data shop, or you're just working on a project by yourself, it may not be worth taking on the overhead of picking up Spark. You may just be better off with something like Pandas. Okay, And of course, I can't do any talking about tooling without bringing up automation, because I think automation is just so important. Because automation can help you save time, improve the quality of the data, and it helps you really learn about your processes when you are automating it, because you're having to break what is maybe a bit of like a more vague process. You're breaking it into procedural steps. And last but not least, I've interacted with so many people over the years who they're just like, they're the person that they process X file every week. And they have to plan their vacations around that. And that's, very unfortunate. So if you automate something, that means you can document and share it with someone else. So some general steps for automation. You really want to keep your process as simple as possible from the start, and pick the process you understand best, because, that's the one where you can really just take it, break into little parts. And you don't want to get too hung up on future proofing, because more often than not, when building any scalable data solution, the first iteration is not going to be your last. More often than not, in my experience, whenever I built a platform, I'll usually build the first platform, I'll iterate on it to a point, and then usually there's a point where you do have to kind of do a scrape and rebuild, as some may say, where you take those lessons learned from building out that initial iteration and you can build something better. But if you get caught up in trying to future-proof things, it reduces your cycle, your iteration cycle, and you don't get as many quick wins, which oftentimes when you're manually processing data, you really want to get those quick wins to kind of get business buy-in around automating your data process. Awesome. So now I'm going to get into environment management. Before I do that, what is a computer environment? A computer environment is the context in which your program or application is running. That could be, in Linux, it's very simple. Think about it as your command line. And same for Windows. I mean, when you're running your command line, there's a series of embedded variables in your system when you're running any application. That being said, you can add to your environment, and this can be really useful for doing things like configuration, secrets, programming packages, and even the operating system dependencies. You can manage that all with Docker. Okay, using environments to manage your configurations. One example of this, and a great way of using environments to managing configurations, is between your concept of like a production and development environment. And for those, if you're not working in industry, the concept of production and development is essentially, production is what is currently operating in the business to actually like solve a business problem, and development is usually a space where you are able to do active development, try things out. If you break it, it's not the end of the day. Production, you don't want it to break. But when you use environments to manage your configuration, it allows you to develop your local application in a very similar way you deploy to production. So when you do that process of deploying to production, you're not having to manually change any code. You just get to deploy. And later on, I'll cover something called continuous deployment, which leans heavily on this concept of using your environment to manage your configurations. Secrets management. A secret is, some of you have probably heard about secrets, but really at the end of the day, a secret is just like your password, or an access key or an API key, anything that is used to do some form of authentication with a system. Using your environment to manage your credentials, it makes it just a lot easier. You never want to hard code your username or password into an application for two reasons. For one, it makes it so sharing it is a little challenging, because every time you share it with someone, they're going to have a different username and password, and it can be very cumbersome trying to remember to delete that username and password from the application. Second, it's just not secure. You may forget and you do that git commit with your username and password in there, and you could potentially compromise the system. So using your environment to manage your secrets, in Python, it's super easy. You just, import OS, you pull out from your environment. It's a very easy way of storing your secrets outside of your project folder, import it into your environment, and then you can use it within your project. Programming virtual environments. So I'm sure, can I get a show of hands of how many people have built a Python project in this call, and they came back to it a year later, and that project didn't work because you didn't use a virtual environment. You had changed programs. You've installed different versions of the packages over time, and a year later your project just didn't work anymore. I know I have. And that's a very common problem. I didn't get turned on to virtual environments till later in my career, and to me, it's as a Python person, like it's night and day. Using virtual environments, like I personally like Poetry, but there's many others out there that it allows you to use specific versions of Python packages when building any data project, and whenever you come back to it a year later, as long as you have those project configurations set, your project will guaranteed run. And this happens because over time, packages change, features get deprecated, features get added, features get slightly changed. Especially if you work in the data science space doing machine learning, it is very critical that you pin or you kind of manage your versions of packages, because slight changes in how a calculation is done could significantly impact the results of like a machine learning application. So using virtual environments to manage your packages is really important. Oh, yeah. And last but not least are containers. So containers are if your environment, like configuration secrets, virtual environment, if that's all within your kind of command line, but it still exists in your overall operating system, a container does it all. It is going to not only include your local environment, but it's also going to create a fully self-contained operating system with its own environment. This is really, really helpful if you're wanting to ensure that, say, you build an application that you want to say runs across any system. Most things I build these days, I'm building it in a container because it makes local development super easy, and then I can deploy it to AWS, very streamlined. Yeah, it's just super helpful. Or if I'm sharing a project with someone who's a Windows-based user, I'm a Mac person, I can just hand them my project. They can run it just fine, because a container contains your operating system, all those operating system dependencies, as well as any type of built-in environment considerations. Docker is kind of the main tool in the space, but Podman.io, Podman is another popular tool that I consider a competitor. Okay, now on to programming languages. When thinking about programming languages that would most help someone derive value from business, that's the approach I took when coming up with this list. And that, hands down, SQL is the most impactful language that anyone can learn when it comes to trying to get into working in data. Most organizations are going to have their data in some sort of relational database that you can work with. And, so SQL was a no-brainer for the top of the list. Second item I thought a lot about, and shell scripting. I actually decided that was my second pick, because I think there's a lot of things that people overlook when it comes to shell scripting, whether it's Bash, Z Shell, PowerShell. If you're a Windows person, there's a lot of things that you can automate locally or streamline locally using shell scripting. And I think it's more often than not overlooked when a lot of people are getting into working in data. Of course, the third is Python. Python is the, kind of hands down when it comes to like data processing languages. It's the king. It's the language that everyone kind of compares to, because it can span data engineering, data science, machine learning engineering. It pretty much does it all in terms of the data space. Next, I would say is R for data science. And these next three are kind of 4, 5, and 6 are all kind of on equal terms and their specializations. R, I realize that I've been talking about this, but I also have specific slides on these. So sorry about that, y'all. R is a great language for data science because of the fact that it does have a lot of built-in statistics for doing statistical analyses, but it does lack a lot of the engineering aspects that you would really want when building a robust data application. So it's great for data science, machine learning, statistical analysis, but it's not really the, I'd consider a full-fledged data application language. Java and Scala are both really good data engineering languages. Java's been around for a super long time. It has the same support as Python with respect to cloud platform and data frameworks. And Scala is really popular because of Spark. I'm sure a lot of you have heard about Spark. And Scala is built in Spark, and with that has made it a very kind of popular engineering language. Last but certainly not least is Julia. Julia is a data scientist machine learning engineering language that has kind of come out the couple of years ago. It's built for kind of solving the performance issues of Python. So allowing you kind of build those kind of high performance applications doing data science activities like analytics and even machine learning. So to go back to my list, so are there any other languages? So I saw JavaScript. Are there any other languages anyone would think would be on there? Curious. JavaScript is a great language. I've done a little bit with JavaScript. I think it's great for, especially if you're doing like web-based analytics. There's a lot of value there in terms of, doing a lot of website. Okay, so Visual Basic, DAX. DAX, that's interesting. So yeah, DAX is, that's true. DAX is I definitely, especially if you're doing a lot of like Power BI, data analytics kind of work, DAX is a very useful language. So to kind of sum up this section, why do I think Python is better? While R is great for data science, it lacks, like I said before, it lacks a lot of features for building production applications. And why do I think Python's better than Java, Scala, or Julia? While all of these have benefits over Python, Python still leads kind of in the following areas of, it can do engineering and analytics very well. It has, in my opinion, a lower learning curve. I know that's a bit subjective, but in my opinion, you can kind of get going on Python a little easier. And last but certainly not least is that Python has a very large market share. When you're trying to get a job in data, most organizations are doing data in some form or capacity. So that's where Python really does come out above these other languages. And then the last thing I have for this section is, should you know multiple programming languages? This is a question I really get a lot. And I think for people getting started, no, I don't think it's really a good idea to pick up multiple languages at once because it can get really overwhelming and confusing. My recommendation is to really SQL, shell scripting, and then pick one programming language. Which programming language you want to do and focus on that. Every programming language has some nuances to it. And it's good to kind of pick up one, understand it, master it, and then you can consider picking up others. I personally am I do a lot of Python and R. I picked up R because I was, one company I was at, I was supporting a data science group and they did all their stuff in R. So by nature, I picked it up myself, and I kind of jump between those two languages depending on the kind of work I'm doing. But later on, should you know multiple languages? Absolutely. I think it's a good idea. I think learning a language, you're going to learn different patterns of that language, which will kind of help inform, better design decisions. What shell do I recommend to use? Depends on the environment. I mean, in Windows, I'm not as familiar. I know there's PowerShell. I've done a little bit of PowerShell, but I'm not super familiar with it. I do know PowerShell is a pretty robust, it's pretty robust shell scripting language. In terms of Linux, two really come to mind. You have Z shell, which is a newer shell, and then you have Bash. I typically, when I'm building shell scripts on the Linux side, I err on the side of Bash because it's just more commonplace, and more often than not, if you just write because you can run Bash compatible scripts in Z shell. I personally use Z shell for like my command line because interacting with Z shell is just a lot more. I just enjoy it better. And also, Apple kind of made that decision for me when they kind of pushed out Bash. Perl, that's an interesting language. That's a language I haven't done much with Perl or Ruby, but based on my understanding, I know Ruby's that's like a web-based language. I don't know. I know it's for building scalable like web applications. Okay, the last section I have is around development tools that kind of can help manage your data solution projects. First tool, I'm sure it's no shocker to anyone, source control. All code and non-secret environment configurations should be managed in some form of source control. This is beneficial because I even have, like, when I'm doing scratch work where I'm just kind of hammering stuff out, I'll even manage that code and source control, because you'll never know if at some point in time down the road, you work on some little side project and you realize, oh, there's maybe some value in that. I typically manage that. I just call it like my sandbox repo, where I just kind of throw ideas in there. It's so useful. I know there's a learning curve to it. There's a lot of materials out there on kind of helping you learn it more. But especially if you're wanting to get into industry, I'm hard pressed to find many data teams that aren't using some form of source control. Popular platforms, that all have pretty generous free tiers are GitHub, GitLab, and Bitbucket. Cookie Cutter, which is a templating tool. Cookie Cutter, I got turned on to Cookie Cutter a couple of years ago, and I've become a huge fan of it, because what it allows you to do is to create a project structure or a project template. And this is great for, say you're working on an analytics team and you want to streamline how people approach, structuring their analytics projects. You can create a cookie cutter template of how they should place it. You have your data folder, your reporting folder, your data processing folder, however you want them to structure their project. You can create a cookie cutter template, and then it will help improve standardization. But it also helps reduce the amount of time for getting a project started for people. This is a super useful tool. Highly recommend it to any organization. If you're wanting to help with improved standardization, highly recommend checking out Cookie Cutter. Code formatting and linting. Code formatter is, as it kind of sounds, it's a utility that's going to format your code for you. This is really helpful because it kind of just ensures consistency across the team. There's been a handful of times where I've worked at some companies where I'll look at a pull request, and 90% of the pull request is someone reformatted the code just because that's how they felt about it. Formatting can become a bit of a heated topic. So that's where using a utility to do it kind of takes the opinion out of it. My personal favorite code formatter for Python is Black. I've been using it for a couple of years now, and I'm a huge fan of it. And a code linter is a utility that helps improve code quality. So while the code formatter kind of helps ensure your code's kind of all formatted and structured the same way. A code linter is going to help with code quality in ways where, such as if you define a variable and then you delete the function or you delete the reason that variable existed, a code linter is going to help detect unused variables or unused imports, which can help ensure that your code stays better quality, which better quality code is easier to maintain. So Flykgate is the one I use. I know there's a handful of others out there, but I definitely recommend using some form of code formatter and code linting, regardless of the one, your preference. Automated testing. This is something that, obviously getting your code in source control, using some sort of code formatting and linting, those are the things you should tackle first if you're not doing those things. But if you're doing those things and you have those things down, next I'm going to recommend automated testing. This is going to just really automate the process of checking your code. So you make a change to your code. You want to see, did I break existing ways this code is being used? And you really want to try and do that because you don't want to push out a change to some system and it doesn't get caught until some wrong number shows up in someone's dashboard or product. It's much easier to catch the error as early as possible because you kind of prevent having to go back to it and figure it out. There's a couple types of automated testing. You have your unit testing, which is your traditional software kind of unit testing your code where you define a function and you write tests around how that function should operate. Integration testing is where you are, you have your code and it interacts with another system. So you're seeing that, you're testing that interaction between your platform and another platform. And last is something specific to data is data testing. This is something that I think gets overlooked a lot of companies, but building in data testing is so helpful in the sense that it really just ensures that you're not pushing bad quality data into your data warehouse. It could be as simple as making sure, a categorical column doesn't have something that it shouldn't have. If your options are red, blue, and green, and if you get orange, you want to flag that sooner than later. Otherwise, it can break your software application or can make your dashboard look weird. This is something that you can do with a couple of different ways around doing this. Great Expectations is a really popular Python-based way of doing this, but there's also a lot of tools out there that are really focusing on helping improve your overall data quality through data testing. Continuous integration and continuous deployment. So what continuous integration is it takes the process of whenever you've built your unit test. Continuous integration is just streamlining the process of running those tests before you commit your code. You push your code, your branch, which for those who aren't familiar with source control, typically when you have your main branch, and then depending on your source control strategy, you'll do a couple of different ways, but you're always going to create a branch when you're implementing something new. So continuous integration is going to run a series of tests on your code prior to you merging that into something else, whether that's a release branch or into the main master branch. That's all continuous integration is. Continuous deployment is the process of when you merge that code, when that code finally goes into that main production branch, it streamlines the process of deploying it into your environment. This is really good because you take out of the loop anyone accidentally making an error when it comes to deploying your application into say AWS or Microsoft or wherever it is. It's an automated process that just happens. This also means you're getting features out faster. So you're not having to, the concept of deploy on Friday, don't deploy on Friday, or we're going to deploy on Monday. If you build out a good continuous integration, continuous development system, you're not having to think about it because all you're doing is you're building your code, you're testing it, and then you're merging it in. And kind of you're good to go there. The last section I'm going to cover is cloud computing. Cloud computing especially if you're interested in getting into data. I mean, a lot of, I don't know of many companies that aren't doing some form of cloud computing these days. I personally got into cloud computing back in 2017. I've been doing predominantly AWS. I've done a little bit of Google Cloud and a little bit of Azure. But I highly recommend checking out their free tier. All of their free tiers are pretty generous, where you can spin up a server, a database, and interact with them pretty easily. I am not certified in a cloud tool. I'm looking at the AWS certifications. Part of that is just time for me, but no, I have looked at it. I know AWS has a lot of resources around getting certified in their platform, and I know Google does as well. But I do think there's value if you're looking at getting into data, and you don't have an opportunity to get practical experience. I was fortunate. I came on at a startup and I was able to get that hands-on experience with cloud computing. I think getting certifications in cloud computing is a really great way of kind of boosting up your resume and showcasing to an employer that you've taken the time to learn this tool and get their certification. Should you experiment? I don't think so. I think I know for AWS, I think their first level certification is pretty attainable. Their first certification, which I think is really great for anyone, because what it essentially helps you do is just get a good understanding of the broad services at AWS. You know, what is S3 and what is its purpose? You know, what is Lambda? What is EC2? I think going ahead, getting that first certification for AWS, I can't speak for the others. As far as getting additional, how about anonymizing the data? I'll get to that in a second. As far as getting additional certifications, I do know that there are recommendations around certain amount of years of cloud experience. But yeah, going beyond that. So anonymizing data, that's a great question. So could you specify, are you talking about creating test data, or taking data that has sensitive information into it, scrambling it or encrypting it, and storing it in that encrypted state?
Exactly. It's hi. Exactly. It's about, you protect the data to not allow other people see it. You scramble the data, you take social security numbers,
Absolutely.
Things like that.
Absolutely. So that is, so there's a couple of ways of doing that. Usually I'm going to use some form of platform. You can do that in, off the top of my head, you could use some form of, it's been a long time since I've done that, but I have done it, and it's, you could do some form of encryption key where you store the key in a secure location and you encrypt the column. I know a lot of services are coming out to try and help with that. Like you have services like Lake Formation in AWS, where you can specify in a column whether or not it should be visible or encrypted. That's also maybe a governance layer where maybe not, maybe instead of trying to encrypt it in place, you will instead just not serve it up. So you only serve up information that is pertinent, such as, on birth dates. Instead of giving the day, maybe you just do the month and year, because a lot of the information about someone's birthday, their age, you can get from either the year and maybe the month.
So there's another point of anonymization. It's about, when you transfer data from different regions, like Europeans cannot have their data flowing to another country. It's you have any experience?
I don't have experience. Yeah, and I think you're referring to like GDPR and stuff like that. Yeah. I don't have experience working in that. I've worked in environments where I spent about 5 years working in healthcare, and obviously when moving the data into our environment, we encrypt it, move it around, land it in our data lake, and then we decrypt it and we pull out, we have to do some analytics with the sensitive data. And then we would use the governance tool to ensure that none of that sensitive data was being served up. And of course, access control, only necessary access was provided. In terms of like, international standards, I don't have any experience, working with that. And most recently, I actually moved into the environmental sciences space. So I don't have to work with sensitive data, because working with sensitive data significantly complicates any kind of data platform. So
How about the database? No, which database are you working more often on?
So being an AWS person, I'm a huge fan of Redshift. I've built a ton of data lakes using Redshift, and I use Redshift with dbt data build tool. Snowflake is another really interesting cloud data warehouse. And to take a step back, you asked about databases. I'm assuming you're talking about analytics databases for like data processing, and not like OLTP databases like Postgres and stuff
in
like
general,
that.
in general.
Oh, in general?
Yeah.
Oh, I mean, for OLAP, analytics processing, I like Redshift and Snowflake. Athena is an interesting, I wouldn't call it a database, but it allows you to query data directly in S3. In fact, I recently built a data lake using built a data warehouse on top of data lake using Athena, because the data volume I was working with, it's in the gigabytes of data. And I was able to build the data lake at about $5 a month using Athena with S3. And so Athena is an interesting option. Athena itself is just a managed service by AWS, which is Presto on the back end. In terms of like OLT databases, I'm a huge fan of Postgres. I've been using Postgres for years whenever I'm working in some form of like software application setting. But I also know, I don't have strong opinions on that. I've done a little bit with like, Django and Postgres, but not a whole lot. But yeah, in terms of cloud data warehousing, Redshift, Snowflake, and Athena are probably my three favorite options for like a database. In terms of data processing, you have EMR, which allows for, to spin up a cluster, to use those distributed computing technologies, Elastic, Amazon's Elastic MapReduce. And then their Glue service has really appealing services around helping kind of manage your, different aspects of the data lake, from your managed high metastore with their Glue catalog to serverless Spark processing with their Glue PySpark running module.
Very good. How about data or transferring data from different sources like Airflow or any other?
So are you talking about like, so when I think of like integrations, I'm thinking like Fivetran, but it's not, you said Airflow, so you're thinking orchestration?
Yes.
Okay. So integrations, Fivetran is okay, you were saying orchestration. I'll get to that in a second. But in terms of integration, so there is a suite of tools called like integration tools like Fivetran, Airbyte, Meltano. These are all really good tools if you want to streamline the processing of like pulling data out of Salesforce, LinkedIn, any type of like, a lot of different SaaS platforms, Facebook. If you want to just essentially, instead of managing that yourself, you can create a configuration and use these tools to streamline the process of landing these in your cloud data warehouse. So if you're doing anything with like Salesforce, Facebook, or anything like that, I highly recommend checking out Fivetran's kind of the leader in this space, but there are open source alternatives like Meltano. In terms of orchestration, Airflow's, I would say Airflow is probably the king in the orchestration space. I'm personally a huge fan of AWS's managed service step functions, because while Airflow is great, you still have to manage infrastructure. And where possible, I've been shifting my design paradigms, and I don't know what time. I could talk about this all night. What time do I need to be? I just want to be cognizant of the time that I need to wrap up.
Yeah, we should probably end questions pretty soon. I'd like to
Okay.
have Yingquan starting by 7.
Okay, absolutely. So we'll just button this up and
Yeah, we
real
can
quick.
always have more discussion during the networking session after both
Absolutely.
talks are complete.
Absolutely. Orchestration, yeah, just general. I've been shifting a lot of my design patterns to doing serverless just because it reduces the amount of overhead in terms of maintenance, because using serverless technologies, you're just running your code with the configuration on a managed service. So it's just one less thing you have to keep in mind. With that, that's why I like step functions. But if I was to use like a service, Airflow is the most popular, and I think it's probably leader in the space.
Thank you.
Last but not least, I have a series of sections at the end here. I'll be sharing these slides, and this is where I kind of went into a bit more detail around like when I'm developing in SQL, what are some considerations I have, developing in R, Python, different R utilities, stuff like that. So thank you everyone for having me. Thank you.
Thank you so much, Alex. There was a lot of that definitely hit home in terms of stuff that I've picked up on the job, but definitely not necessarily in preparation for a data science job. Yingquan, are you ready to give your talk?
Yeah, I'm ready. Can you hear me?
Mm-hmm. Yep.
Thank you, Alex. That was great. Congratulations. I'm about to give my talk, and it builds up. It builds on your talk. So I think we can get started right now. Presenter view. Can you all see the presentation? Yes.
I can see the presentation, but I can also see the presenter view.
Oh, okay.
And yeah, it's in front of the.
Okay, I'll move the presenter view. Can you just see the presentation now?
Yep.
Okay, well, all right. So hi, everyone. I'm Yingquan. I'm an engineer. I'm working for a research lab at U of Penn right now, but previously I worked in industry for many years, public sector as well as private sector. So I'm really happy to be here to give you this talk. Okay, so I have 6 sections. I'm going to try to be mindful of the time as well as give you the details too. This is a deep dive after all. The 30,000-foot overview, the CLI, advanced CLI tools. This builds up on what Alex talked about: Python environment management, versions, dependencies, etc. Jupyter notebooks, Q&A. Okay. So this is a quote I found: all the best people in life seem to like. It's a 5-letter word. It's of course Linux. And so let's go through the overview. So what is Linux? It's a free and open source operating system that was developed by Linus Torvalds in '91. Linus is credited with writing the Linux kernel, which is the main part of the operating system. And the kernel is the interface between the system hardware and the user processes, such as commands, jobs, etc. What's interesting, and this builds up on the previous talk, as they were building Linux at the time, they needed a tool to, manage all the developers from around the world in a distributed manner. What was the tool that they developed to manage the development of Linux? That tool was called Git. So that's Linus, and that's a very famous email that he sent back in '91. So how specifically it's cool to know and hear about Linux. How does it actually work? Okay. It's built on top of what's known in computer science, which is known as abstractions. At the user level, you're working with applications and libraries to build software, but underneath that is that kernel that I was just talking about. And what are the 2 fundamental components of the kernel? You have the file system as well as network protocols that are wrapped by 2 different layers. You have high-level APIs and abstractions that talk with the applications, as well as low-level interfaces that talk to the hardware. Does that make sense? Is there any questions so far? Okay, well, I'll carry on then. Basically, everything in Linux is an object, and it's organized into what is known as a Linux file system hierarchy standard. It's delineated by the Linux Foundation, and it maintains a structure for the Linux OS. At the top, you have the root directory, but beneath the root directory, you have many different, different segments of the Linux file system. And, the file systems is, frankly speaking, quite intimidating for beginners, and different distributions of Linux have their own flavors of the file system. It's not like a rule, but there's only 2 rules that you really need to know. Is that number 1, when you're debugging, please look for advice that pertains to your Linux distribution only. And the practical tip number 2 is you only need to go into the directories under root often to modify configuration files. You should never be deleting any files under the root directory unless it's in your home directory or the temp directory. That's basically the rule, is that you go in there to make modifications and just don't touch anything or delete anything. That's really the key trick to it all. There are different flavors of Linux: Arch, Debian, Fedora, OpenSUSE, CentOS, Ubuntu, etc. And you can choose whichever one you want to use. That's not the important thing. Now, what's interesting about Mac is that why is Mac considered very popular among developers, technologists, right? Well, the Mac's terminal, for all intents and purposes, is basically a perfect Linux-like clone, but it's not Linux. It actually based off of a flavor of Unix called BSD, but for all intents and purposes, it is Linux. There is really no differentiation between the Mac terminal and Linux. But if you're using Windows, it's very difficult with all the dependencies. But with Mac, because it's so basically a perfect clone of Linux, it makes downloading libraries development much easier. And for those reasons, that's why developers really like Mac. That's the real reason, So that was the overview. Now we're going into the CLI. The way that you think about the CLI is very simple. An expert user really needs to know the CLI like it's muscle memory. You should be able to know the commands that you don't need to look at a reference. You don't need to really just be typing a command and then looking in your book. That's not the way to go. You should be able to develop advanced abilities so that you know how to use the commands, and if you don't, you know how to search for the commands. And now we're going to do I'm going to do a demo in real time. I'm going to do like more of like a freestyle to give people a sense of what it's actually like when you're really working in the weeds. I don't really have like a prepared demo in place. I'm kind of doing sort of like freestyling. Can you all see my screen right now?
Yep, we can see it.
Okay, I'm going to bring up some commands, and I'm going to start off with some keyboard shortcuts. You got to know these keyboard shortcuts. Very important, All right, here we go. So let's start with the basics, right? Control A moves you to the beginning of the line. Control E moves you to the end of line, okay? No one has time to be pressing the left key all the time. You got to memorize these keyboard shortcuts like it's muscle memory. Control A, Control E. Now we're going to do some, do something else. Okay, so how about Control U? That will cut the line, okay? So you don't need to press delete all the time, And then I'm going to bring up that command again. Now I don't know where my command is, right? So now I'm just going to use a history command. That will bring up my command. You see that? This was a command that I was just using, and I'm going to bring it up again. I never memorize anything. So Control U will cut from the back, but now I'm going to bring it up again, bring up the command again, And then if I go to if I change some commands together, Control A and then press Control K, that will move to the beginning and cut from the beginning, right? So now I'm going to bring up another command. I'm going to bring up that command again, right? Let me bring up that command again, Let's say I want to go into the middle of the command, right? I could keep pressing the left arrow, but if I hold down the Option key, the cross will allow me to just click in the middle, right? Now I want to cut to the left of the word, and I press Control W, and that will cut the line. And then I could chain commands together, such as Control E, I press space, and then I press Control Y, and that will paste, So to really get an understanding of Linux, to become an expert user, you got to memorize, and frankly speak, the keyboard shortcuts have to be kind of like muscle memory. Okay, any questions here? Okay.
No questions in the chat so far.
Okay, so now I'm gonna show some rather advanced commands right now. So one of the most useful to me is history. It brings you up the list of commands that you just used. Well, you see these numbers right here. To execute the command, you can just press the exclamation point and then press 5, the number, and they will actually execute the command that displays in the history. Okay, history is a very, very useful command. I think a lot of people know about the command grep, right? A lot of people know about the command grep. So I have a names file right here, and I'm just going to do some examples of grep. The most basic usage of the word grep is you type in the word grep, and then you type in what you want to find, right? So I'm going to find John Williams, and in my names.txt. So you do the word grep, your search string, and the name of the file, and then you find it, right? But as with anything in Linux, there are options. I can press the -W, which will find words, right? I can also find -I, which will find even insensitive cases. That will give you insensitive cases of the string, as well as I can press the word N, the letter N. It will actually give you the line numbers. So you can actually do a lot for it with this command. You can also do something such as this. You're looking for the word John Williams, but you also want to find the line that's right before it. So you can press the word 1, and it will give you John Williams, but also get you the line that's right above it, right? So these types of things are most commands. There are many different options. I strongly suggest that you learn a command as well as the many options. To me, what makes someone like an advanced user, some advanced commands will be history, grep, find, tree, symbolic links, alias, piping, networking, as well as using the exclamation point, which if you want to run a command that you previously don't remember, such as I ran some SSH command, I just don't remember. If you type the exclamation point, press SSH, it will actually execute it for you. You see that? So that was just a demo of like navigating the CLI. Is there any questions? Am I going too fast? Am I going too slow? Anything? Okay, I'll keep going then. So that would, as someone who's able to navigate the CLI in Linux, that's great, right? Being able to navigate CLI, but what would be something that's somewhat more advanced than just being able to do stuff on the command line? To me, what would make someone like a real advanced Linux? Oh, I see some questions. We can run, man. Okay, I'll follow up with the questions after. But to me, some of the more advanced commands will be screen, tmux, cron tabs, systemctl. This goes back to what Alex said, bash scripting. It's very important, as well as configuring SSH. The things I want to highlight today are probably screen as well as SSH, maybe cron tabs, but let's do another demo right now. Okay, so I just ran an SSH command. I don't remember it, but I'm gonna do SSH. I really want, and then now I have the command. Now I can type in history to grab my Where did my SSH command go? Hang on, I'm sorry. SSH. All right, well, see, so this is kind of like real life coding. That's okay. I have the example that I pasted right here. But the key, let me do something right now. Control K clear. Then I'm going to bring up my SSH command, Control A, and then I'm going to delete. So the way SSH works is that SSH, you always need a PEM file as well as the user and the the host that you're connecting to. So how SSH works is that it's a system where you give the private key to the host, and then they have the private key, but you have the public key. I mean, you give the public key to the host and you have the private key, and then it does a three-way handshake so that all the material that you submit over to the server is encrypted, So you always need like either a PEM key or a file, but the way it is, it's you have a PEM key, a user, as well as a the host, and then you can connect to the host, right? And the host stores your public key in a place called /.ssh, cd /.ssh clear. And another command that's actually really useful is clear. I really think that when you're working with Linux, it's just frustrating, like to see stuff. Clearing it gives you a nice screen, but let me do cat authorized keys. These are the public keys of different users, and if I'm not mistaken, my public key is in here somewhere. But you give the public key to the host, but but in your own SSH environment, you have the public key. You have the public key, but you always keep the private key. Don't ever give the private key. And it's this public key cryptography, the three-way handshake that makes it so that your connection is encrypted, as well as the data that you send to the host is also encrypted. Okay. So SSH can be very tricky for a user, but I highly suggest that you learn it well. So then I would suggest screen. Okay, how do you use screen? Screen is a terminal multiplexer that lets you run multiple different processes at the same time. So I'm going to do a screen ls, right? Nothing. So I'm going to create like a screen, and I'm going to do s like window 1. Okay, now I'm actually in the window. You see that? I'm not in my normal window anymore, but to return to the main menu, I do Control A D, and then I do screen -ls. I have a screen. Let me make another screen. Let me make it a second screen. Let me make a third screen, And the good thing about screen is that, let me do clear, very useful command I just showed you about, -ls. When you have different screens and you let them run in the background, even if you're connected to a host and you have screen enabled and you're running a process or some kind of daemon, even if you lose the SSH connection, the screen window will keep running in the background. So if you want to run a command or a program overnight on some remote computer, use the screen and then let the screen just keep running in the background. Okay, very, very useful. And I don't really have like I'm actually going back. I don't really have like a cron tab example I can show you, but the last two I wanted to show you was cron tabs. Basically, it's a way to run different commands at a specific periodic time. You give it like a specific time, and then you say run this command at this run 5 minutes after midnight every day. You just use these regex look like these things look like regexes, but you just define them as well as give you a command. And this is a really cron tab guru is very, very useful to figure out when exactly periodically do you want to run your cron tabs, right? This is the first one is minute, the second one is hour, the third one is day, the fourth one is month, the fifth one is day. Okay, so I just went through SSH, screen, as well as cron tabs. Any questions?
Yeah, there's one question. So one thing I wanted to add to the screen portion is it's helpful with using screen because you can set something to run and then just close the program, and then it's still running in the background. I think that's the biggest advantage to using screen. There is a question in the chat asking about, would you recommend tmux over screen?
That's a personal preference. I found tmux to be rather challenging to learn. I found screen to be a little bit easier, but they're basically the equivalent. They're both known as terminal multiplexers, right? So what exactly is a terminal multiplexer? You know, as Ann said, you can run stuff in the daemons process in the background, and you can just like sleep and not do anything. But in my opinion, I found tmux to be rather challenging to use. I personally just use screen. Yes. And I just want to make another point that system CTL is a service manager. You know, it offers on-demand starting up daemons, tracking processes, maintaining auto mount points. This goes back to Alex's point about automation. If you really want to become like an advanced Linux user and be able to automate stuff, I strongly suggest learning bash scripting, of course, and learning how to use system CTL very well. I found that the bash scripting is very useful, but system CTL can automate systems, processes, daemons, etc. Start and restop services. It's a very useful tool, but I found it rather challenging. I would consider myself a rather novice that's still trying to pick it up, and I've been using Linux for many years for sure. Okay, let's keep going. All right, so you know, now we're gonna talk about Python environment manager. This is something that's very important for a beginner. Beginners often just download Python libraries to their global environment, right? Pip install, conda install. But there's a danger in that, you know, when you download something globally, it's there across the board. You know, what happens if the package gets updated? What happens if the package gets deprecated? What happens if you have dependency conflicts? And to me, one of the biggest things that a data scientist coming into the field is going to realize is, and what's lacking is that, and you can only learn this through trial and error, trial by fire, learning on the job, is package management, Python environments. You know, it's one of these situations where you can't, it's one of these situations that if you were introduced to package management earlier, it may enhance best practices, you know. So I'm just going to introduce three of them. PyEnv, tool used to isolate different Python versions. Virtual env, command line tool used to isolate different Python environments. You can isolate different Python versions plus associated libraries. I highly recommend it. A lot of people recommend Anaconda. Man, but Anaconda itself is it's pretty powerful. You download it, you can just do stuff right away. You know, it's a powerful tool. But man, does it come with a lot of bloat, you know, and it's pretty intensive. So if you want to do Anaconda, I highly suggest some kind of tool called the alternative Miniconda, right? Miniconda, highly recommend. So now I'm going into my demo again. I'm going to do some freestyling. I really don't have like a demo prepared, but as you can see, like I'm debugging, troubleshooting problem. This is what working in real life is like. You know, you're not going to learn anything. So what do? You look it up, you troubleshoot, you debug, right? So so let me see. I had like a tutorial I found the other day, and you know, of course, real tech people, you know, you find a tutorial and try to implement it, right? So all right, let's see what we're gonna do. Clear, you know, cd. All right, so okay, so now I'm gonna do a command. I'm gonna just rip from this tutorial I found. All right, so I'm gonna do a Python 3 -m meetup talk, and you know, I'm going to do env. No module name meetup talk. Okay, all right. So I need to create the environment, right? All right, so let me create the environment. But you know, I think I believe I created something already. Okay. All right, so Python install Python -v creating a virtual environment. Okay, so Python 3 -m env. All right, let's see if this creates my virtual environment. It's doing something. All right, so I think it created the virtual environment. Can you believe that? Okay, here's a virtual environment, right? Okay, so what did that actually do? Like, how do I manage my Python packages? How do you manage my Python environment, right? Well, you actually had to go into the virtual environment, you know? So now let me activate the virtual environment, right? Source env/bin/activate, you know? There we go. Now you know you're in a virtual environment because it has the name of the virtual environment right here, you know? So now you're in a virtual environment, you can do whatever you want. You can do pip list. You know, I only have like pip, right? So I can do whatever I want in here and just like install XXX, and it really wouldn't matter. It really wouldn't matter. You know, you can really you can install and work in this environment, download libraries you want at a specific version you want, and really there's really trial for error because it's isolated. This environment's totally isolated from your global environment. So if you make a mistake, that's fine. I mean, really doesn't matter. And if you make a mistake, you can literally just say deactivate, you know, and now you're out of the virtual environment, right? And if it's just a bad environment, you can just totally remove the environment, you know, and it's gone. And it's gone. So you never have to deal with that environment. That's really the power of what Alex talked about. And what I'm showing you now is like isolating your Python libraries and versions in the virtual environment so that you can so that it's modular. You know, you're not dealing with dependency help. Like you install scikit-learn and it doesn't work with GCC, you know, and it's the wrong version. That's what happens when you just download stuff like globally, like pip install in your global environment. Does that make sense? Is there any questions? Okay, I see one. Do you use ASDF to manage Python? I've never heard of ASDF. No, I've never heard of that one. Alex, do you want to elaborate?
I'm not familiar with ASDF either. I use PyEnv for managing my different Python versions, and I've been using that for. So I use Poetry for managing my virtual environment. I like that combination because it's super easy to install just whatever version of Python I want. And then whenever I'm setting up a project, you know, I will, you know, whatever Python, yeah, I go between 3.8 and 3.10 a lot, depending on the project needs. I can specify it there.
Can you make an example about advantages of VENV in Linux environment compared to Windows? Isan, can you speak up and tell me exactly what you're trying to say? I'd be happy to if you could provide some more context.
Yes, sure. Hi. It's been several years that I'm working in Windows, all virtual environments and data science stuff. I'm about to just become familiar with Linux and everything. Everyone keeps saying that about advantages of Linux. I just want to know, for example, an example for the case that you just mentioned, working with virtual environments. Is there any advantages compared to working with Windows, in working with virtual environments?
You want to know the advantages of working in virtual environments versus working on Windows? Is that what you're saying?
No. Working with virtual environments in Linux compared to working within virtual environments in Windows.
I understood. Linux versus Windows. That's what you're saying. Okay. So the advantages of Linux is, frankly speaking, the reason why Linux is more of an advantage over Windows, and this is Mac, by the way. This is not Linux. This is the terminal is a flavor of Linux that's based on BSD, but for all intents and purposes, the Mac terminal is basically Linux, right? So let's go to the root directory. Let me do tree. All right, so One other command I really want people to know and memorize is tree. Okay, very, very useful. You don't need to find files. It just basically prints out the directory for you. The biggest advantage of using Linux versus Windows is that the operating system is more amenable to open source. You know, if all the developers are developing on Mac, right, and they're writing software on Mac, and they're pushing out open source software on Mac or Linux, then the software that you're going to be working with in data science are, frankly speaking, just going to be more compatible with Linux or Mac. Versus Windows, you know, do developers develop on Windows? Absolutely. Do they put out code to the internet open source on using Windows machines? Absolutely. But is it just a smaller percentage of developers using Windows versus Mac or Linux? Yes. So often what happens when you use Linux is that, or when you use Windows, is that you may try to download like a tool or some kind of software, and then you get frustration with dependencies, libraries not working correctly. That's the real potential issues with Windows. I remember, I'll give you a use case as a specific example. I tried using Docker with Windows one time. It just wasn't happening, you know, it just didn't work. And then I moved over to Mac and it worked just like that, you know? And these are, you often notice stuff like that, software that, and by the way, most tutorials are also written for Mac or Linux, by the way. If you look up some data science tutorial or like some programmer tutorial, trust me when I say this, they're mostly written for Mac or Linux, okay? And so for those reasons, the compatibility is why you would want to use Linux and or Mac, you know? So does that make sense?
Yeah, thank you. So you're saying only because the vast amount of majority are using Linux, it's more preferable than the Windows?
Does someone else want to chime in here? I'm sure there's a lot of experts here.
I mean, I'd say it depends on what you're trying to do. Windows, you can do, and it's not that I would say there's really nothing you can't do in Windows versus Linux and vice versa. You can do it all. It's just how easy it is to do it. Like Kron was saying, like there are certain steps to installing something like GeoPandas, which is like a couple commands in Linux, but in Windows, there's a lot of manual interaction because you're having to use installation screens and stuff like that. It's just how Windows is built. There's a lot of interacting with installation, where in Linux, it's a lot of command line, which just streamlines a lot of aspects of it. I'm pretty, I would say most data teams I've worked with have been Linux based or Unix based, better to say, you know, going between Mac and Linux, but also at the same time when I was working at larger companies, they were all Microsoft based because Microsoft has the market on enterprise IT versus Mac and or Linux, which Mac's making, there's some third-party vendors that are making strides in the enterprise space, but it's just lacking. But like someone else made a comment before, yeah, all cloud is Linux based. So, you know, even if you're interacting, you work locally in Windows, once you get into the cloud computing, all of that's going to be Linux based.
Yeah, Mike has a great point
Thank you.
here. Yeah. Historically, Linux is a clone of Unix. There used to be only closed source Unix distributions. Gotta say, it really warms my heart to hear Max described as basically Linux clone, which is effectively true since it's based on Darwin, which is kind of BSD. That's correct. Mac terminal is not Linux. It's basically, it for all intents and purposes, it is Linux, but it's really not. If you look under the hood, technically speaking, it's not. All right, here we go. So I highly suggest virtual env. If you want to use Anaconda, I highly suggest Miniconda, so you're not dealing with dependency hell. All right, I went through a demo. I know we're running short on time, so I'm just going to, you know, everyone knows Jupyter Notebooks. Alternatives include Amazon SageMaker Studio Lab, Zeppelin, and others. You know, Jupyter Notebooks, I've often found like installing it, getting it up can be a little bit challenging. I found that, by the way, with Jupyter Notebooks. So I suggest Google Colab as an alternative to, you know, to prototype. You know, I also, Amazon AWS just came up with their SageMaker Studio Lab, which is also a free IDE to do prototyping development. But I highly suggest Google Colab if you want to prototype stuff quickly. I think it has like 5 GB of storage too. Very, very popular. I think everyone knows Jupyter Notebooks, so I won't belabor that point. And, you know, yeah, I think I'm on time. So thank you very much. I hope this was of value. And if nothing else, like, I hope you can see from my freestyling that, you know, with any of the technology, the last point I want to make is that you learn by doing. You know, you're not going to learn by reading a book or just continually watching tutorials every day. You learn by doing, you know, and if you do that by either doing that at work or working in a hackathon or your own project or something, but make sure that you're implementing quickly, and only through implementation and doing will you really become like a Linux master. Okay, thank you everyone.
Hey, thank you so much, Yingfan.
Okay.
So at this point, I'm gonna stop the recording and then we can transition into our networking event.